Hi, my name is Avery Berkowitz, and in this lesson we'll be discussing Linux security. Unfortunately, securing your web server isn't quite as simple as this. But don't fear, by the end of this lesson you'll understand why it's important to secure your Linux or server of any type on the web. You'll learn common steps that we need to take to do so, and finally you'll learn how to configure your very own AWS Lightsail Ubuntu instance of a Linux server. See you in the lesson. As the internet continues to grow in popularity, so too have cyber attacks. As seen in this graph from 2009 to 2015, cyber attacks have gone globally from 3.4 million a year to nearly 60 million in 2015. This is quite alarming and definitely exponential growth. Some of the world's most popular websites and organizations have not been immune. From our voter data to our credit card information to even our social media profiles, hackers have been able to compromise the security of servers across the globe to access our information. So where do we start to prevent this from happening to us? While security can be a very complex issue, with entire departments of companies working on it, we can take 4 simple steps to make sure that our own server is nice and secure when we start. We can first make sure our server software is up to date, then require key-based authentication. We can change our SSH port, and finally we can configure our firewall to only allow necessary connections. Much like your computer or cell phone, the software in your server must be updated. This will help fix any bugs or known security concerns that have been found since the version of Linux that you are downloading and setting up has been released. In order to update my server's software, I first need to create an instance using Amazon Lightsail. I'm going to choose OS only, Ubuntu 16.04, the free edition here, or at least with the first month free, and that should be it. After waiting a few minutes, your server should be up and running. So let's connect to our instance using SSH. Once our terminal starts up, we can type in some commands to look for any packages or software that need upgrading. We'll first run the command sudo apt-get update to look for these packages. It'll take just a little bit, and I'm going to fast forward here. Now that our server knows which packages and software needs to be updated, we have to use the command sudo apt-get upgrade to actually make these changes. Again, remember the sudo is necessary because we need the root permission to be able to make these changes. Let's go ahead and run that now. We might have to hit yes here, and we'll let it run. Once we see our username in the command line again, we're ready to go. That should have taken you a couple of minutes. As a web developer, it's really important that you have access to your server from your local machine. But to do this securely, you should use key pair authentication. On your local machine, you'll set up a public and private password. The private password will be something that only stays on your computer. And the public password will be something that you put into the configuration files on your server. In order for you to connect, the private password and the public password will match with each other. Now, they're not the same password, but they sort of talk to each other and decide whether or not they were the original pair that was created on your local machine. And if they are, you'll be successfully able to connect. Let's see how that looks. On our local machine, we'll use a built-in application called SSH Keygen to build this pair for us. You'll be asked to define where you would like to save these keys. I've chosen to save them under my username in the .ssh directory, and I've named the keys key_demonstration. When we press enter, we can choose to create a password for extra protection, I will choose to not do that in this case. And you can see here that our program has created both a private key, doesn't have anything at the end of it, and a public key, noted by .pub. We can take a look at the public key using the cat command here, and we can see a really long string of numbers and capitalized letters and lowercase letters, followed by this username here, and you can see it's the name of my computer. I'm going to go ahead and copy this key, as we will need to put it on our server in just a moment. By default, our server already comes ready for key-based authentication. So all we have to do is add our public key into the correct file. To edit and access that file, we can use the command nano.ssh/authorized keys. And you can already see there is a key that has been stored here. What we want to do is add our very own key. Using this clipboard at the bottom right, I was able to paste in our public key into this file. Let's go ahead and save it by doing Control-O, pressing Enter, and we can exit by hitting Control-X. Now let's try logging into our server from our local machine. Back in our local terminal, I've typed in the command that you see here. Note that I have our username, our public IP address, and this I tag that links the path of our private key. We'll be asked the first time if we're sure we want to connect. And then finally, you see that we have successfully connected, and we get a very similar screen to that of our instance from the Amazon website. We are now connected to our server from our local terminal. It's also a good idea to change the port through which our SSH connection connects. This will help protect our server from automated attacks that are looking for port 22, which is the most common SSH port. Let's change it to port 2200. In order for us to change our SSH port, we have to do a little bit of configuration with the built-in firewall in Amazon Lightsail. Go to the Networking tab, and you'll see here that we can add a new connection because our current SSH is through port 22, like we said before. We can change that to add a custom TCP port of 2200. It's a good idea not to delete any ports until you've already had everything set up. Back in our local terminal, we can access the SSH configuration files using the following command. Remember, we must use sudo because this is an administrative task and we need that root permission. Here, what we want to look for is the line that says port. Yours should probably be set to 22 as a default. As you could see, mine was already 2200. Once you make that change, you want to hit Control-O, Enter, and then Control-X to exit out. We must also restart our SSH service to see these changes in effect. Let's do that now. Once again, it looks like it's important for us to use the sudo command. So let's see if that works. And it looks like we're good. So let's log out of our server using Control-D. And this time, what we want to do is add this P2200 tag. If we don't add this tag, you'll notice that we can no longer connect through port 22. And so let's try it with the 2200 tag. and we are able to log in just like before. Lastly, it's time for us to configure our firewalls. A firewall is a really useful tool that allows us to only let through connections that we want. We follow something called the rule of least privilege, which means that we should only allow connections that we need. A second ago, we changed our SSH connection from port 22 to port 2200. We want to ensure with our firewall that only requests through port 2200 actually make it. Right now, because we set our port for the SSH connection to be 2200, port 22 technically will not work, but our firewall would actually let it through the way that it's configured right now. So let's make sure that our firewall is only following the rule of least privilege, and also that our uncomplicated firewall is allowing the connections that we need. This second firewall, called the uncomplicated firewall, is something that when we turn on in Ubuntu will automatically default and block all connections. So we want to be really careful and make sure we allow all of the appropriate connections before we continue. Back in our Lightsail instance, we want to make sure that our firewall only allows the SSH connection that we need. Here you see we have a connection through port 22 and through port 2200. That does not follow the rule of least privilege. So let's go ahead and edit rules, and we can go ahead and delete the port 22. We'll save our changes, and now our firewall should block any attempt to connect to our server through port 22 and only allow us to connect through port 2200. We can access the status of our uncomplicated firewall by typing in the command sudo ufw status. As you see here, it is defaulted as inactive, which is a good thing, because if this was active right now, it would block all connections and we would actually be unable to connect to our server. We want to make sure that the default for our uncomplicated firewall, once we turn it on, is to deny all incoming and outgoing requests. And so we can do that with the following commands. First, we're going to run sudo ufw default deny incoming to make sure that the default is that all incoming commands are denied. And we can do the same with outgoing requests by using the same command, except for incoming, we're going to use outgoing. We still haven't turned our firewall on. And so before we do that, we want to make sure that our SSH connection will still work. So we also need to allow our connections through port 2200. We can do that using the following command. Sudo ufw allow 2200/TCP. And we'll see here that the rules have been updated. Since we're most likely going to host a web application, we also want to allow port 80. And you'll see that that's the same port that we had back on our actual Amazon Lightsail networking page. Once we've updated all our rules, all we have to do now is hit sudo ufw enable. It will give you a warning, because if you don't, for example, have port 2200 enabled, then you're going to be kicked off of your connection. But we do have it, so we'll be good. And you'll notice here that it says firewall is active and enabled on system. If we now go ahead and hit our status, you'll notice that we have our 2200 TCP connection allowed, and also our 80, which is for HTTP requests, also allowed. Congratulations on configuring and securing a Linux server. You can now host your web application and not be worried for your client's security. Their data should be very safe in the hands of your server. Congrats and happy coding.